Yeah. That's pretty cool. Good question. Have to ask her. Okay. This is the Note Well. Hopefully you're familiar with this by now at this point in the week. This is a new one. It covers not only the intellectual property terms of participating here, but also things like working group procedures, anti-harassment, code of conduct, and copyright, which is IPR as well, and the privacy policy. So if you're not familiar with this, the best thing to do is to go and look up IETF Note Well on your favorite internet search engine. Our agenda for today, we have one session this week. We've done the blue sheets, correct? They're flying around. Yep. We have scribes, thank you so much. And right now we're doing the agenda bash. And so we're going to go over our active drafts as quickly as we can. And then we're going to talk about a related piece of work, signed HTTP exchanges, and then some work that's been proposed for start sooner, which is HTTP TER, which we've talked about a few times, the SNI alt service parameter and the alt service via DNS, and variants. Do we have any agenda bashing? Anything else? It's a pretty packed agenda. So, okay.
Settling for 2.5 hours of HTTP fun.
Let's get going.
Yeah. So with that, I think BCP 56 bits, one of our active drafts that
Sure.
Mark's the author of, is up first.
So I don't have any slides for this draft. BCP 56-BIS, for those who don't remember, is the revision of the use of HTTP as a substrate draft. And that was put together in the early part of this century based on current practice then. Current practice has moved on quite a bit. And so we're trying to write that down again. I don't have much to say about this except that we seem to be making pretty good progress. I think we're not quite done yet. More examples, more details, and certainly more review are required. But there aren't too many open issues on it right now. So if you haven't already, or if you haven't for a while, please have a look at the document. Make sure that it makes sense to you and that you're comfortable with it, and raise any issues or have discussions as necessary. Does anybody have any feedback based on the document as it sits right now? I've heard, I have had some people review it, and the feedback has been pretty positive, which I'm really happy about, but we can always improve it.
I will make the comment that it has been actively used in a couple other scenarios outside of this working group, which is actually its designated audience, right? So I think even though it's still at the internet draft stage, it's been a useful North Star in the work in Doe, and I was able to reference it in ATLS, which is really at a BOF stage, but it's been a very useful sort of thing to point to say, how does your design flow against this? So hopefully we could expect some comments from those constituencies, as well as on its usefulness, as well as from this room on its correctness, right? And as with anything, we want to publish. We're interested in hearing a diversity of voices that say, they've read this works for me. So some discussion would be necessary before we get to the end. But I have read it, and I'm pretty happy.
And we're trying to walk a line with this document where it is not draconian. It's not saying thou shalt not or thou shalt must do this or whatever, but more, as the status intends, it's best practice. This is why you should probably think about doing this way, and so forth and so on. So if you see a place where you think it is still too draconian or is not on the mark, please bring it up. We'll talk about it.
I would say the best experience with it in Doe has been that it solves the temptation to redefine redundantly various parts of HTTP, because it can be a reference, thereupon, which is nice. Okay. So any comments to the microphone about that draft, or should we move on? All right.
No? Okay, great. Next up is bootstrapping WebSockets. Patrick. Oh. Be with you in just a moment.
I know which way those rockets are going.
Are you sure there are slides? Oh, there it is. It's a long name. What a fetching background. And seasonally appropriate.
There we go. Spring in London. All right. Next slide. All right, here's the wrap for where we are. Last time we met, we discussed an individual draft of mine, and we essentially reached consensus shortly thereafter on the mailing list and in the meeting on refactoring that draft to include a similar level of header information in the H2 request that was going to bootstrap WebSockets as the old style HTTP1 version used. I had played around with a couple of schemes that tunneled that at a different layer, but the working group kind of liked it the old way. So that's what we did, and we adopted that document as OO in the IETF Internet Draft Working Group adopted document stream in December. The only changes since then have been editorial in nature. Thank you, Julian, making it better. And we've had a successful browser implementation, which I'm hoping to get Ben's to come up and say a couple words about when we get to comment time in Chrome, and several independent server implementations that has worked against with OO. So that's kind of the state of things. I essentially have two issues I am aware of that I'm happy to talk about in my 10 minutes today. My personal goal here is that if we can get through those, that I feel the document would be ready for working group last call, but of course want to hear any other comments that might be out there. Next slide. All right, so if you don't know what I'm talking about, this is what OO looks like. In order to use WebSocket protocol, which is RFC 6455, in HTTP1, you more or less use the upgrade header, which changes your whole TCP connection to start speaking 6455. We left upgrade out of HTTP2 because things that operate on the whole connection are a bad idea in a multiplex protocol. And so the corollary I have chosen here is to use a stream in place of the connection that was previously used. So the way this mechanism works, you get an opt-in from the server that says, I understand the funky new semantics you're then going to use in the next flight on the left. And the next flight on the left uses the connect method to build a tunnel, very similar to the way a bidirectional byte stream has traditionally worked, but with a few slight differences. The primary one being that there's a protocol pseudo header on here that defines how you route and terminate that tunnel instead of routing to a new IP address as Connect might normally do through a proxy. The other request headers there are typical WebSocket 6455 stuff, the same stuff that was on the GET in HTTP1. The next flight says, okay, that's great. It includes its own set of WebSockets headers doing sub-protocol negotiation. And then you just use the H2 stream back and forth as if it were a TCP session that had been upgraded. Next slide. Okay, so we have one GitHub issue open here, which says consider using ALP and registry values for the protocol pseudo header. The draft uses the upgrade registry currently, which corresponds to the same tokens HTTP1 uses. Fundamentally, this means that you send a protocol pseudo header with a WebSocket value, which does obviously not exist in the ALPN registry, which tends to have things like H1, H2, whole connection. And my rationale there is that we don't want a whole connection-based protocol value. What we're looking for is really the semantics we had with the upgrade registry. So my recommendation is close this without action, but there was no further discussion, so I wanted to raise it. Oh yes, I am pausing for further discussion.
Yeah, Martin Thompson, I hate to do this to you. So someone suggested to me that there's an inherent problem with this proposal in that if I want to make a WebSocket connection to a server that does HTTP2, I don't get to know that the server supports HTTP2, and I can't sort of force the situation in any way. To use this design, you sort of have to choose HTTP101, and that way you know that it's going to work. You're going to be able to negotiate WebSockets in that case, or you have a reasonable chance of knowing that they're going to support that version of WebSockets. So what do you do?
I'm sorry, so you've upleveled and you're describing the case where there's no connection at all? I mean, that's what you're
right.
describing.
So you get given a WSS URI and you faithfully go off and connect to that thing over TCP. Which right. ALPNs do you put in that to have the greatest chance of success? Now, obviously, this is the best way to proceed, because then you get to use the connection for other things as well. But
Well, I mean, I'm not sure we need to prescribe that. That could be an implementation choice about how you want to do that. You could happy eyeballs it. You could do a few different things. My approach would probably start by thinking about whether I wanted to use the connection for different things, right?
you always want the connection for other things, don't you?
Right. Well, then I'm probably going to happy eyeballs the thing.
All right.
But we can hear other points. Does that tie closely to this question, or is that just more of a method?
Well,
it ties loosely, certainly.
Loosely, in the sense that if the answer to that question was ALPN, and I think your response I'm quite happy with, suggests that it doesn't, then no, it doesn't read on this. But there was the potential here for this to say, well, I need an ALPN, and then it's sort of, now we're down the rabbit hole and creating ourselves other issues. But if your response there is no, and the answer is work it out for yourselves, people, sorry, and we just document that side of things, which I think is probably okay. I don't know what other browser implementers and other WebSocket implementers, this is largely a browser problem. What do other browser implementers think about that?
Eric Niger Nakamai. And I think that is somewhat decoupled from this, because in some ways this issue is about the ALPN for the protocol version, but I think there's that question whether or not for the H2 with connection protocol, it's worth having a H2 with connection protocol ALPN token that you could put before HTTP101 and along with on the list when you're making a WebSockets connection.
So we have resisted bundling options with protocol versions at negotiation time, and I don't think this is a big enough use case to motivate that.
But it may mean that if you don't do that, you end up getting stuck with HTTP101 in a lot of cases, because you can't. Actually, I'll let an implementer talk.
Hi, Ben Becky from Google. First, as Patrick asked me to comment very briefly on the state of implementation, Chrome has an implementation. It's rough around the edges, but it seems to work. There's 2 server implementations I know of, NGHTTP2 and libWebSockets. The respective developers set up publicly available servers for testing and confirmed that they were able to make it work with Chrome. I have not tried myself, I'm sorry. There's a 3rd implementer who I'm corresponding with privately. It doesn't work yet with them. Second, to contribute to the discussion that Patrick just prompted about this particular GitHub issue, I support Patrick's recommendation. I don't think that connection level ALPN registry is right for protocol values. Third, to respond to Martin's concern about there's no way for the client to know in advance whether the server does support WebSocket over HTTP2 or not. And this is a performance issue, because if I open up an H2 connection, even if I have previous knowledge about the server, having supported WebSocket in the past, I need to wait a round trip to receive the settings from the server before I can send a request. So I'm kind of inclined to just send the WebSocket request according to the specification at the server before getting the setting, because if the server doesn't support WebSockets over H2, it's going to fail anyway, and then I can retry on H1.
We also have Craig. So, all right.
Oh, sorry. I'm just in the queue for my 10-minute slot after his. Sorry.
Okay.
We'll come back to Craig.
Get back in when it's time. Thanks.
Okay.
So, Martin Thompson, to the performance point, I think that's an eminently reasonable thing to do. I will also point out that in TLS 1.3, the server can send its settings first, so you won't have to worry about that particularly much in the future. So it's a temporary problem, and certainly not a particularly dire one. So, yeah.
All right, thank you. One more slide, one more issue. Okay. So the other piece of feedback I've gotten, it doesn't have a GitHub issue open. I've received this primarily from Mark, and I know we talked about this briefly in Singapore, as it was the same in my individual draft, is that this mechanism is built around the connect method. And the argument for using the connect method is that, connect is a special snowflake, which, is consistent with the background on the slide, so it must be the right choice. And that everything surprising about, connect is exactly what we need in this case. So it satisfies the principle of least surprise, that there's only a small change in behavior. The behavior around connect being that it, terminates to a protocol version instead of terminating to another host, as it traditionally does. But the sense there's a special snowflake, and in every code base, which is quite a few I've looked at that implement HTTP, connect is really handled in a different code path because it needs to bidirectionally process a byte stream, which is considerably different than the somewhat store and forward oriented, message semantics that go on with some other other methods, including unknown ones. I would summarize, the argument against is that, creating a link level modification or a hop to hop level modification, using a different, a modification of a method is itself quite surprising, and you could use an alternative method in a quite totally new namespace, like, get with upgrade or something like that. And that could be a bit cleaner. I have concerns around that. If that method is referenced at all outside of this hop-top semantic, its meaning is totally undefined and isn't like rooted in any kind of behavior. So, comments? I'm sure. Julian was in line, but does not want to comment.
Could I respond to that first, actually? Thank you, if that was the intent there. I would state it a little differently in that I want to make sure that we consciously do this, which is have a protocol version specific extension in HTTP2 setting override the semantics of a generic HTTP method. And I think your point about it being a special snowflake is very well taken. It's always been weird. And it could be that maybe the outcome is we decide connect is the most appropriate thing for this, but it's something that we document in HTTP tour that's not a good practice, generally speaking, for the other methods.
Seems pretty reasonable.
Yeah. Julian.
I've got another thing that probably is not tracked on GitHub, but I think we discussed that before. What's the story about defining new pseudo headers? I think the spec said we can't, but this one does.
Yeah.
So minimally, it would have to update the HTTP2 spec, right?
No. So I think first, maybe Mark's comment that, talking about the scope of these kinds of things in TUR is an interesting thing to do. But 7540 is pretty clear that the settings mechanism can be used to redefine aspects of 7540 itself, which is what's going on here.
So Martin Thompson, I just put two and two together, and Vance's comment about sending one of these requests to a server that may or may not support this. I just realized that if you're going to put this new pseudo header in a request and send it to a server that you haven't received settings from yet, I predict, based on the general posture that we took in HTTP2 regarding stuff that we didn't allow, explosions.
Right. So
can we avoid that?
Well, we can by reading it because TLS 1.3 sends first. And that's a problem actually not just with the proposed here. It's true of any of the proposals I've seen to be able to do this. We don't have the semantic we need for this, so we need an extension of some sort. A new method that has this behavior is also not really good.
Well, no, that's not cool either.
Yeah.
Is there some way we can ensure that the connect would fail, but that the request would otherwise work? So you want a signal from the server that you want to make sure that the server does not accept this request.
Mm-hmm. You want one of our must violations
Predictable
to apply
fashion.
to the stream, not to the connection.
Because
no.
An unrecognized pseudo header will blow up not just that stream, but the whole connection.
The whole connection. That's
Yeah.
what I'm concerned about.
Yeah.
I want the connection to the
Persist.
stream to explode and
Yeah.
the connection to be okay.
Exactly.
It's true.
And
that-
this design doesn't give you that.
Yeah, and none of the designs we really looked at can give you that without either, this essential opt-in, which we hope is solved mostly by server sense first, and saying that the primary use case is being able to use established HTTP2 connections, right? for which this is known information, right?
Right. That's easy. Maybe the suggestion is to change the use of the existing pseudo headers rather than define a new one. Or is the behavior you're looking for explosions? Speak.
I do not seek to explode the internet.
I was thinking that it's going to fail because it's missing an authority header, which is required with Connect. Am I right? But then it's also got this protocol one, which is going to probably break it. So that may break the whole connection or not. But you're looking at it fine.
It has an authority.
I'm sorry, Alan Frendel, Facebook.
So it sounds like we have a new issue potentially, or at least something to think through and make sure we're comfortable with it.
Well, I mean, I think we did. So we can revisit the issue. So the resolution of that issue was this is negotiated, and negotiations take a round trip, and maybe that's settled because it doesn't require bilateral negotiation. So if service ends first, it's a half a round trip, right? And that this is the scope of the use case. I mean, we have this discussion in Singapore. We can revisit it, but we don't have really a solution space that is no opt-in.
Okay. I see the queue growing and I see the clock ticking. So
Just while I'm here, I wanted to mention that Facebook also has a nascent implementation, and there's significant interest of people, the developers internally, to use it. So
and
Alan Frendel, Facebook.
if the folks in queue could clarify whether they think that this is something that needs more discussion, or they're comfortable with the current design, that'd be very helpful.
Mike Bishop, Akamai. I just want to point out that currently what the HTTP2 spec says, and that governs until you get the server setting, is that if you have a different pseudo header, the request is malformed, and you must treat that as a stream error of type protocol error. So,
A stream error.
Not a connection error.
not a connection error.
All right,
You're
good.
allowed to upgrade. You're always allowed to make it a connection error, but that's an
Okay.
implementation question and not a hard spec.
Good to go. Thank you, Mike.
Yeah. Martin Thompson, we kind of screwed up there, but that's okay. That's okay.
I'm surprised to learn that. Yeah.
Okay, so back to the original issue, which is on the slide, is everyone comfortable with modifying the semantics potentially of connect with a setting? I don't see any great discomfort.
Or is anyone
Makes me
so
feel
uncomfortable they have to insist on
Right.
blocking it?
And we can talk in turn about whether or not that's a good practice more generically without affecting this discussion. Okay,
Thank you.
thank you. And maybe we can also talk about pseudo header extensibility as well. Is that your book, How I've Abused the HTTP Protocol?
I'm looking for a section enter.
Okay, that takes us to random access and live content. Craig, can you come back? Please come back, Craig.
Craig, I see you published a new draft.
To be fair, Darshak, I got it published last night. So, yeah. So I guess I don't really have any slides today. Just wanted to draw attention to the new draft. We've just had editorial changes and one clarification on the shift buffer representations. And since it just went out last night, I can't really expect people to have reviewed it. And hi everybody. And I apologize for not being there again. Someday maybe I'll make it. So more just trying to draw attention to the new draft. It's not significantly different from O2, mostly editorial, thanks to Julian and Martin, and also thanks for the feedback on shift buffers. But I'm willing to entertain any questions right now that anyone has. I'm sorry if my face is like 10 feet tall because I don't have any slides there now. I didn't think about that.
You look good. You look good.
Oh, well, it's morning.
So there has been a little
Okay.
list discussion. So when Mark and I were, discussing this in our regular meeting, what we were looking forward to was getting a sense from the working group of whether, they thought this effort was substantive enough and applicable enough to enough different people that it was worth going through the publication process for, and since then, I mean, Mark, feel free to weigh in, but there have been, a number of comments that I think have been very positive to see. So I think, my primary question is, what do you think you have left before last call?
Yeah, and thanks for rattling the cages and get everyone's attention. I think that's what helped us get some feedback. Nothing really. I mean, that the one area I kind of expected there to be a few clarifications on is exactly where we've had them, which is in that last section of our draft regarding these shift buffers. There's one question out there that I'll answer on the mailing list, I think, that has a pretty clear answer. And so no, there's nothing I can think of. I mean, this is I'd like to get this draft to bed. I don't want to add anything to it. I mean, if somebody found a fatal flaw in the shift buffers, I was ready to that section is autonomous really from the rest of it. Well, I don't know if that's the right word. It's discrete. So we could, not even discuss it. The core portion is really about the range on live non-shifting resources, and I think we're pretty solid there, but I'm always looking for feedback. So,
right, Martin.
I have a suggestion. I think we should working group last call this document.
Right.
We've had a lot of people look at it, and those people are now largely happy. And people can pay extra attention to the shift buffers section in that working group last call. That's not unusual for us. Not unusual for us to do that. Mm-hmm. But otherwise, I don't think we need to hold on to this document any longer. I think we're good.
And if you'll recall, we already had one working group last call, and it was a fairly long one. Yeah. I think the next one can be relatively short, say 2 weeks. So Craig, unless you have any concerns, I think we'll probably start that after the meeting.
That's great. I'd like to look at other things. So this one's hung around long enough. So I hope.
Would you call that last call BIS? All right.
Yeah.
Thank you, Craig.
Thank you.
Don't quit your day job, Patrick.
We can move on to...
Just jumping up to quote something from Jabber. Q for Craig, 416 in failure mode's absent. See, this is Tom Peterson. See my last email on mailing list. Any reason why?
So this is the question about resetting and shift buffers. Is that the question you're referring to? Oh, whoops. Am I gone?
I have no idea. I'm quoting from Tom Peterson.
Right. We don't have a very thick channel.
So my suggestion would... Go
ahead. Sorry.
Go.
The answer really to that is that while a server may internally utilize a real circular, what you call a circular buffer, to implement a shift buffer, there shouldn't really be a concept in the representation of resetting. It should always move forward, and if it's ever used for any other content, it should be a different representation with a different URI. That would be my answer to that. I mean, so that you can't internally have this model of a circular buffer, in my mind, using HTTP if you want it to be cacheable. It always needs to move forward. That's my answer, I think, to the question.
Martin Thompson, that's a great answer. I don't think we need to write anything down for that.
Okay.
Yeah, I think if there's anything I can be faulted at, is maybe the use of maybe finding a better name other than shift buffer. People keep thinking circular buffer, but I don't know how to get that out of people's heads, I guess. But anyway.
Okay. Thank you, Craig.
You're welcome.
So we have the secondary certificates draft next on the hit list. Mike Bishop going to have some things to say. Oh, Mike, come join us up here. Let everyone enjoy you.
Pink box, Mike. Pink box.
Well, I wasn't sure I needed to walk all this way to make a short statement, but sure. So we adopted it last time around. We've published it. We have merged the integration with exported authenticators, which is making progress in the TLS group. We still have one real open issue, which is handling cases where the client wants to offer a cert because they expect the server to want it, and negotiating things around that. And the bigger meta issue that crops up in that is how we're using frames on on streams with requests that may have already ended, which in HTTP2, it's all a TCP connection. You can send a frame that references a closed stream and nobody cares. In HTTP over QUIC, that doesn't work so well because the stream is actually gone. So we need to find a different way to deal with that, which is probably sending on the control stream. I just haven't done that yet.
Thank you. Hey, don't go away, Martin.
Yeah.
Mike.
So Martin Thompson, the other thing to point out is that there's a lot of activity going on this work in TLS, and until that resolves, a bunch of this stuff won't really be able to be buttoned down anyway. So we're working in parallel, but we're primarily focusing on the work in TLS.
Right, and that was understood when we took it on, so we're happy to let it bubble along for a while.
And it's good to know that relationship is going well. You know, you put your peanut butter in my certificate and vice versa. I actually think this is going to be a pretty important, draft to the future uses of HTTP. And I sort of wanted to draw people's attention to that to make sure it got, fairly wide review. So if this is not on your radar, it's mostly just largely a reframing of the crypto work that's being done in TLS, but nonetheless, make sure you take a look at what it can do. And if you have, opinions on that, you know where to find everyone.
The capabilities are interesting.
Yeah. The implications for HTTP are interesting. The actual, the work that has to be done on this document is not a big deal, but the implications are, significant.
Yeah. Next up is expect CT. Oh, we have a comment.
Yeah, actually. So I've looked through the draft. Sorry, Ryan Sleevey, Google. So I've looked through the draft, and in particular, it seems, I think how you framed it, it's a rethinking of how we think about the TLS crypto. I mean, quite simply. And from talking to various server operators, it seems like one of the things that is not yet addressed on the draft, and I'd be curious to hear how the authors plan to address, is it addresses client risk, meaning the client may want to look at DNS in addition to the certificate frame if the server sends a certificate indicating it has an additional thing. But one of the things from talking to server operators is this potentially allows wide-scale attack undetectably if you can obtain a compromised certificate. Through this method, you obtain a certificate for, and I'll use google.com as an example, and you have a connection, and you can advertise that I am authoritative for google.com. In today's model, you have things like BGP detection that you can use to detect this, but this would no longer apply. And so I'm trying to understand, and I did not see discussion on list on these security concerns yet. I'm just curious if there's a way forward with that.
So I'm not one of the designers of this, but Eric Scrolla, but I spent a lot of time thinking about it, just like to make sure we got our terms straight. So in the existing design, if I'm able to get a compromised certificate for google.com, then and I'm able to fuck with DNS, then I can mount serious attacks. Sorry, then I can mount serious attacks. We agree about that, right?
Right.
So
or BGP.
Or BGP, yes. Yeah. So your concern, I'm going to take this out so I can don't feel like a dork. So your concern is that this relaxes the DNS requirement and it's just compromised certificate, right?
Not only relaxes the DNS requirement or the on path. You no longer have to be on path.
Yeah, right. Sorry. Yeah. It basically says no matter what the network topology is, if I have a compromised certificate, it is now game over, right?
Correct. And the detectability of that, the mechanisms based on detecting network path changes or DNS compromise no longer apply to mitigate these concerns.
So I think you absolutely accurately summed up the situation. And there was a bunch of discussion about this, and I think that the working group kind of felt okay with that. But that could be, that's certainly something people are aware of, but that may have been the wrong decision. And so if you want to relitigate that, I'm not going to object.
So it's not captured in the draft right now.
And to be clear, the relaxation of DNS was done in the origin specification, and that's in the RFC editor queue.
Right. The relaxation of DNS was done in the origin. My highlight here, though, is that the security considerations list on the client may be concerned with this, right? And steps the client may want to take to provide a sufficient level of assurance, such as optionally checking DNS, as the origin frame mentioned. What I'm speaking, though, is the server's ability to detect or mitigate compromise to its own services, right? So in the case of, say, google.com, you could look at BGP routing tables, advertisements, and see is someone, say, Pakistan claiming a YouTube IP. In a case of certificate frame, you no longer have these mitigatable or detectable things. Even if it's after the fact detection, the mechanism disappears. And so the security considerations highlight steps the client may want to take, but not steps for a server operator concerned about compromise.
Do you think you can suggest text?
I honestly don't know, and that's the problem.
So what you just said there was actually pretty helpful and pretty clear, because to that point I was really very confused with origin. So that was a helpful clarification.
Yeah.
And Mike, if you want to step up here, you can have permanent access to the microphone as an author.
Well, there is that. But
So I guess I'm just like tired today, so bear with me. How is this different from the origin frame in the sense that, so if I can acquire a certificate that is for Google and myself, it seems to me that the origin frame has the same security properties that this does. What am I missing?
I think it is very similar.
Okay.
Yeah.
the same.
But the detection now is you at least have, there is some extent of detectability of the Google.com and that certificate, whether, and this depends, right? Prior to TLS 1.3, the unencryption of the certificate, things like that. But the whole threat model itself doesn't seem to be explored as to different levels of mitigations.
Right. So I guess, are you saying we maybe shouldn't do this, or are you just saying we should like write a bunch of text that people may or may not follow?
So we do have mechanisms for detecting certificate misissuance, right? I mean, the certificate transparency work that is the goal of the certificate transparency work, is to detect certificate misissuance. So to say that this removes the ability to detect that there's a problem seems like, we're not giving up on CT, right?
And I believe CT is one of the recommended things for clients to do.
So key compromise, right? CT would totally detect there's a legitimate certificate with a legitimate key, but the service key has been compromised. The attacker can use that key compromise to mount these attacks without the detectability while still having all the visibility of CT.
And I think really that is the difference, in that with Origin, you have to get a misissued cert for your own domain with an extra SAN. And this would go a step further and let you expand that attack to also if I got the server key. And there your protection is revoking the key when you discover the compromise, but you have to find the compromise. And I think that is independent of this draft, but you're right, it is a real operational security concern.
Eric?
Yeah, Eric Nygren. Yeah, actually, I think we're thinking about for Origin, and I still have concerns up front, is that I think how we looked at it was that you'd have CT for detecting misissuance and OCSP stapling as the way to respond. And I think that the case of compromise is one that's not really well covered there. There's kind of another related one that this does make worse is in the case where you have a side-loaded certificate from an enterprise into this CA list. This also makes it worse because that means that a enterprise, for example, could capture traffic much more easily without being on path. Which is it's not compromised, and I know that's a case where we're kind of we're doing this, once you have that CA in there, all bets are off, but it does just make that, each of these, as they combine together, make things a little bit worse.
Kyle Nickerts. I'm also very concerned with this issue on both how it makes it a lot easier to exploit a compromised certificate in mass, and it also makes it a lot easier to target the exploitation. But I'm wondering, if we were to expand on a security considerations on the server side, what options do we even have?
Honestly, in terms of guidance for how you figure out somebody has compromised your key, I don't know.
So we could invent some mechanism where when you went to a site, they told you what list of CAs they could use, and then like later you wouldn't accept other CAs. Is that a good idea?
That wouldn't handle compromise, though.
That would help quite a bit, right? If you had,
No.
Compromise, but with the other one, right? With misissuance, right? I was just mostly just
Right. I know you're being facetious on misissuance. It's actually key compromise that, in terms of thinking, what our threat model is for what the future of the PKI ecosystem is. Because of CT, key compromise is actually because you have these certificates online on active server systems. It seems much more likely that the set of attacks we're going to see over the next 5 years are going to be related to key compromise. And we already see this to some extent. There was a certain, say, CA reseller who happened to keep a bunch of keys handy and local. And so those are the sorts of things that the ecosystem is still dealing with that I think this has a chance to amplify the risk.
Right. So I think right. I think so. That's certainly true. I mean, I suppose so. One thing. I mean, so one thing. The whole things we could do. You could imagine doing, right? I guess one thing I would say is that subcerts do help this a little bit in the sense that you can have the subcert have a shorter lifetime, and then you rotate the working keys. They of course create other problems. I mean, another thing we could do that I just sort of invented now, so probably doesn't work, but is have some sort of weak sauce pinning kind of version that basically where in your certificate it says like, basically not pin me, but do not ever let me be a certificate. Do not ever let me be applied to this mechanism, right? And if you like HSTS pinning, and if you remember that, then that would be a pretty safe thing to omit, like HSTS. But it would also give you a fair amount of protection against this kind of attack. Now, of course, we need to standardize that shit. But I mean,
right, guys, can you form a queue because we're getting confused?
I mean, so I think that it's obviously unfortunate that we've created a situation where we have a new risk for everybody. A new risk for everybody that they can't really mitigate without taking active steps. But that's one possibility. There might be some way to invert that, have it be opt-in, but I haven't thought that through. That seems harder.
Yeah, and that's what you're saying is very similar. We're thinking about this in the context of web packaging, and that's where the similarities between web packaging and certificate frame are very strong, and the mitigation of opt-in versus opt-out, et cetera. I do want, at the risk of pivoting to sort of a second conversation point on the draft, one of the things that did seem missing is it describes a single connection, the processing model for a single connection when you receive these secondary certificates and how you handle. What I could not find really addressed is when you have multiple connections, say the typical web browser, and you already have, say, a connection to, we'll use again google.com as an example, and then you receive the secondary certificate on a separate connection for google.com, how you handle the prioritization selection, things like that. And so that would be the other piece that I would suggest for consideration in the draft, is figuring out what the deconflict sort of scenario looks like when you have these multiple connections. It's mentioned in security considerations as a possible confusion, but not a guidance for implementers as to how to prioritize and select available connections that you have when you do have multiple connections.
The queue is closed. Ecker, you may choose to be in the queue at this. Okay.
So responding to that one, I would be open to a...
Guys, if you're going to do a side conversation, can you do it outside? Thanks.
Yeah, and if I'm responding to your comment. I would welcome some text on that, but my initial inclination is right now HTTP2 talks about you may use a connection for certain domains, and if you wind up with multiple connections that are acceptable for that domain, it already gives no guidance on what to do, and browsers already deal with that. A common case for that is you don't know whether it supports HTTP 1 or 2. You open two connections in parallel because that's what you would do in HTTP 1.1. ALPN kicks in, they're both HTTP 2. And in practice, what winds up happening is one connection closes, never having seen a single request.
So following up on the opt-out suggestion, I think opt-in would actually work pretty well as far as the key compromise base.
Ian?
I was also going to second the idea that, sorry, Ian Sweat, Google. For all the reasons Libby just mentioned, opt-in would make me feel a little more warm fuzzy, because I certainly know of certs at Google where, it wouldn't actually be the end of the world if they got compromised, and then there are others that would be the end of the world. So, we do have different risk profiles.
So the suggestion being to require some property on the cert for it to be acceptable?
I guess so. I mean, I haven't thought this through enough to have a mechanism. I mean, previously when we talked about this, we basically decided this seems scary, but we didn't know what to do about it. I mean, that's basically what we ended up with when we talked about this last week. So I literally have no idea what to do about it.
Yeah.
Okay.
I'm sorry for that. I apologize. I don't have. If I had a solution, I would suggest it.
Okay. DKG, the queue's closed. Thank you. It sounds like we still have more to talk about, and this isn't going to working group last call anytime soon. So, thanks.
But thank you for the substantive discussion.
Indeed. Next up is expect CT. Emily can't be with us, but she sent a summary of where she's at, which I've put on screen. So there haven't been any major changes to the draft in a while, only some minor tweaks to reporting, which I think is mirroring some of the other stuff happening in reporting in other HTTP extensions. The open design issue is whether the header should have include subdomain support. And she's not inclined to add this at the moment unless another implementer comes along and wants it. We're unlikely to implement it in Chrome because it's a moderately complex implementation. The marginal value is somewhat small. So that's a status report. I think it'll sit out there for a bit longer before we think about working group last call. Any comments on this draft? Okay. Next up is header common structure, which is me. And Paul Henningkamp, but Paul Henningkamp can't be here.
Oh, stand up, Mark. Get in the picture.
I'm just getting the slides ready for you.
All right.
I know these Macintoshes can be confusing. There we go. Oh, cool. Spacebar. What's that? Hello. Next slide. So this is structured headers. So as a reminder to folks, the goals of this effort are we want to make it easier and more reliable for people to specify and to parse HTTP headers. There's a long history of people specifying HTTP headers and messing it up, sometimes in major ways. For example, cookies. And we have recently made a somewhat bad habit of putting a tremendous workload on Julian of verifying the different ABNF that people try and put in their specs. So that's not fair to Julian. So we want something better. A secondary goal is to accommodate future encodings for efficiency. So once we have a data model for structured HTTP headers, then we can express that data model in different ways, which means maybe a future version of HTTP could have a more efficient encoding on the wire, especially for things like binary content. The non-goals, we don't want to respecify the syntax or the parsing of existing HTTP header fields. That is too fraught with danger. And we don't want to affect or handle any headers that don't explicitly opt into using the specification when they have to want to use it. Next. So after some discussion in Singapore, we agreed to rebase the draft on a draft that I put together and talked to Paul Henning about. So that's 02. And then in draft 03, we did a lot of refining of the algorithms in the spec, which addressed various issues. We split numbers into integers and floats. And I really hope that ends the bike shedding on numbers, but we'll see. And lots of other stuff like we would throw an error on trailing garbage, so forth and so on. And then we did an 04 more recently, lots more editorial work, changed labels to identifiers, and made some other adjustments. Next slide. So one thing I wanted to highlight to folks is that the current design that we've settled on, you have a number of possible top-level types for use when you define a structured header. So you say, I'm going to define the foo header. The foo header is a structured header, and its top-level type is one of these types. You have to specify that, and more importantly, when someone goes to parse it, they have to tell the parser in some fashion that which type it is at the top level. And that might be with the method name or any other number of programming language-specific constructs, but you have to say, I want to parse a dictionary. Now, the bits below that are hinted on the wire, and it will parse those automatically. You have to validate that the data structure you get is the data structure you thought you were going to get, but beyond that, it takes care of everything for you. So we've got a dictionary, we've got a list. The list doesn't have to be homogeneous. We've got a parameterized list, which is probably the most complex data structure we have. Note that these don't recurse. None of these top-level types recurs. We have an item, a simple item, so identifier or a float, an integer, a string, or a binary content. And that's all that's available. And in discussions with bunches of folks for new headers, we think that this has enough descriptive power for most use cases. It may not be 100% of new HTTP headers on the planet, but it's enough to add some value, and that's what we're shooting for, we think. Next slide. Couple of open issues that would be good to get input on. Number 433, length limits. Right now, the spec specifies length limits on all of the different structures. So it says a string must be no more than, I forget, I think it's 1,024 characters. You must have no more than so many items in a list, so forth and so on. And that's to make sure that there are sane limits so that parsers don't overflow or whatever. Integers are 64-bit signed, for example. This helps assure interop and assists optimizations down the road. And it also means that specifications don't have to specify limits. They can rely on the built-in limits, even though they might be very large. So the question is that a good approach? In previous discussion, some people had said, no, these limits don't make sense. Everyone who specifies a structured header needs to specify their own limits if they want limits. And we don't want to prematurely constrain how many things people use, for example, items in a list. The counter argument, I think, is above, which is that it helps ensure interop and so forth and so on. So that's question one. And question two, if we do decide that limits are a good thing, are the ones we've chosen the right ones? Martin.
Martin Thompson, I like the limits. I think it keeps things sensible for those people who are implementing this. If I had to implement a generic parser and had to do greater than 64-bit integers, I would be sad, because I hate doing that. Every time I've had to do that, it's been painful. That doesn't mean that someone can't go off the path and do their own thing. And that's why I think that it doesn't actually matter too much what the limits are that you choose in here. And this seems sensible. Did you have a limit on the number of items in a list or the number of parameters and all those things? You just didn't put them on the slide.
I didn't put them on the slide. Yeah, they're all in the spec.
But they're all huge, right?
And the intent is, well, and for some definition of huge, the intent is to make them quite generous so that normal uses of headers will never hit them. They're just to give some implementation, some certainty. Personally, my observation is that as much as we encourage people to try and do the right thing, people sometimes when they specify HTTP headers don't bother to specify all the details of all the things that could overflow or be big or whatever. And so having some sort of sanity is a good thing. I'm happy to make them bigger if the current limits make people uncomfortable.
So I'm comfortable. I think you had 256 parameters or something crazy like that.
512, something like that, yeah.
Those are big numbers. If anyone ever decides to use all the space they have available to them, things will explode in other ways. So I'm not concerned about the numbers that you have. And I'm also perfectly content with letting people just go ahead and do that. So I think this is about right.
Julian Reschke. I think it's a bit confusing to put a limit on the number size on the same page as like limits on the number of identifiers, because they are very different things in an implementation. So I think I can be convinced that having limits on the integer sizes are good, but I'm very skeptical about saying 256 identifiers are okay, but 257 are not okay. So maybe we should discuss that as two different kinds of limitations.
So for the purpose that if it makes it easier, let's just consider the numbers right out, because I agree with you. I think that there's broad consensus. There needs to be some limit on numbers. So maybe let's just carve those out for this discussion. Thank you.
Kazuho, I consider this from a extension point of view. And for numbers and strings, you always have the option to extend the spec if you want to include a larger number. So I'm pretty fine with that. So I think that regarding Julian's comment, if we could provide a way to add more than 256 identifiers, then it will be fine.
I want to push back on that a little bit, because the way that it's currently specified, it's you literally go through the algorithm, and if you have, let's say the limit for purpose of argument is 256. If you get more than 256, you throw a hard error. And so then if a header specifies, no, don't pay attention to that, that means that you have to modify, the whole point here is to have generic implementations of structured headers. Now you have to modify generic implementations, and if someone else is parsing the header and they're using somebody else's implementation, they have to have the ability to modify that. So it seems like it's making things worse, not better. Like I said, I think it'd be great if people are uncomfortable with the size of the limits, making them bigger, if that's the issue that people are having. But if we want to have no limits whatsoever, then I get into this, the other concern that comes up is that, well, implementation A, decided that 256 are too many, and implementation B decided that 512 are too many. And then you get interoperability problems in that sense, just like we do for integers, So having some sort of sanity line is, I think, a good thing.
Yeah, well, so I agree with that. And well, I wanted to point out that we could always extend the spec if, for example, we need to send a 128-bit file. We always have that chance, like, adding a prefix to an integer, like LL something.
Well,
so
we can always add, we could have structured headers too and add a new type, for example. I think is what you're saying. Okay.
So yeah, Julian is at the end of the queue for this discussion.
Hi, this is Roy Fielding. I have very limited faith in the notion that this will actually do any good, in the sense that there's always been a standard way to doing HTTP header fields parsing, and nobody actually used it because they'd rather invent their own. But aside from that, if we do this and it's intended for extension header fields in the future, I think it's really important that it be self-descriptive, in the sense that if you have a specific type, if the parser needs to know what the type is before it begins parsing, then that should be visible in the text of that.
Are you talking about the previous issue?
No, I'm talking about, well, yeah, I'm probably talking about that, the whole thing. So, I mean, for this particular issue, if there are limits on how to do a specific element of the parsing, is that going to be enforced by the parser, or is it going to be enforced by the recipient of the header field?
Right now, it's enforced by the parser. And the idea is that if I'm specifying the foo header, I can say it's a list of no more than 5 items. And then a value comes off on the wire. I give it to my generic parser. If the value length is over what the in-spec limits are, so 124, for example, then it will raise an error, and I don't ever see it. I just see the error. If it's less than the limit, I get the full list, and then I have to do my own check to say, oh, I only want 5 members in my foo header. This is more than 5, and then do my error handling.
Yeah, so that clarifies what it is you would expect from the implementation. What I don't understand is, why would you ever want the implementation to end at that point and say, "Oop, the parser made a decision for me"? And what is the correct response after that? Do you end the connection, terminate the stream?
No, no. It's just so when I define, again, if I'm defining the foo header, then I have to tell, I have to specify how to handle the errors in parsing the header. If it's a header that affects the entire stream, maybe I do terminate the stream, but it's probably, well, ignore the header or take some sort of default action because an error occurred in respect to the semantics of that header.
Jonathan Lennox. Some of this got answered in the discussion since I got in mine, but so I think that, clearly specifying the defaults, so that somebody who's not thinking very hard and just says use the algorithm is great. Whether the ability for a specific header to say, oh, hey, we're looking at this. This is something where this is routinely going to be, a 4K string, because for whatever reason you're going to put a 4K string in a header. Maybe that's a bad idea, but that's a separate issue. So we need to override this one parameter. As I see it from an implementation point of view, just as the implementation needs to know the top level type for any given header type, maybe potentially you could also have parameter overrides. So basically the values, which the limits all take default values, but you can override any of the default values on when you call the function, just at the same time if you need to. And I would assume that most extensions would not need to, but if something happened, you would. It wouldn't be a huge headache.
I guess I'm just concerned that is going to be complex in that, potentially these headers are going to have to survive multiple hops and other transformations. In
The line has been cut.
Yeah, sorry, the queue was cut. Sorry. Was that a scribe interrupt or no?
No, it was just a reply.
Okay.
This is just like Python. You pass a thing and say the pass.
The line has been cut.
I guess clever line queue stop circumvention. Yeah, that's good. I guess. Sorry.
Your screen
Oh.
is slept.
I think it needs my fingerprint.
Yeah, just leave your finger over there.
I see what you did there. So I'd be concerned, about the complexity of that. And remember, the whole goal here is not to cover every possible future HTTP header. If a header has, if we decide 1K is the limit, for example, and the header really wants to do 4K, we'll go and define a normal HTTP header, just don't use this framework, or define an extension of this framework as a new top-level type.
I mean, so and I guess the question is, if somebody wrote a spec that said this is just like the generic header except the limit is 4K, then obviously the implementer can either parameterize their implementation or write a custom or fork the code. But either way, it's
sorry. I can't.
So basically, if somebody wrote a spec that says this is just like the generic header except the limit is 4K long,
right?
Then I guess an implementer could either parameterize their implementation of the generic or copy and paste the code and change that one field and treat it as a specific header.
Sure. I certainly suspect they could do that. What I imagine what would happen would be that at least while they were beginning to deploy it, none of the existing implementations would support that, and they'd have interrupt problems that people would have to write header parsers from scratch. If it was a popular use case, then of course, support would evolve, and then maybe that's okay.
Sorry. Julian Reschke, maybe it would make sense to think about length limits in a different way than currently. I mean, what we are really interested in is the complete size of the header field, right? Not how long an individual part of it is. I mean, if I want to send a string that is longer than 1024 characters, I might be tempted to define a list of strings just to get it into the header field. And that's not the intent of that, right? So maybe just specifying the total size of the header field gets us to a better result.
That's interesting, but I want to think about it to make sure that the assumption is going to hold. But yeah, maybe that's the way to go.
So the queue has been cut. I'm sorry about that, but there'll be plenty more mic time. And I think you've got some things to think about. And if we could keep this going on the list as well as in the room, I think that would be valuable.
Do you think a hum would be useful at this point? I don't know. I think.
Do you have a suggested question?
Well, actually, I want to think about what Julian just brought up before.
Yeah, I think so as
that's
well.
an interesting point.
So you'll start a thread about that on the list.
Yeah. Oops, sorry. So 505 strings and identifiers. This is a little more esoteric. We noticed that when you're generating one of these headers, you also have to know the top level type. So that's interesting because, when I let's say I've got a data structure and I hand it to my implementation to generate a header from that data structure. Right now, there's ambiguity between identifiers and strings as to, if I just represent that in the data structure as a string, well, do I serialize that as an identifier or a string, for example? I could annotate that with metadata in the data structure. For example, I could wrap it in an object or something, depending on the language I'm using. But, the question is this something we want to try and address? We could say the current design's okay. You just have to make sure that when you're generating strings, you're generating identifiers and strings, you're not ambiguous. Or we could do something like remove identifiers from the item so that that's not ambiguous anymore. There's another aspect of this that we noticed that I forget, but I think is important. Has anybody been following this issue? I think it's been mostly discussed on GitHub. Okay, this is probably too esoteric for the room then.
Okay.
Maybe we'll take it to the list.
Sounds fair. I think that's your last slide.
Yep, so that's it, except we've had some pretty good participation on GitHub with this. More eyeballs are always appreciated. I think we're about ready for prototype implementations to really prove this out. We'd love to get some more experience with it. And after that, we're probably going to be ready for working group last call. We want to get this one out fairly quickly so that folks can start taking advantage of it.
This is Jeffrey Yaskin. Chrome has at least the beginning of a prototype implementation for the signature header in the draft that I'm going to be talking about soon.
Yay!
Let the minutes reflect Mark shrieked.
Julian, I've got one issue that I sort of brought up on the list, but didn't think through until this morning. The way it currently is specified is essentially profiling the HTTP header field list syntax in a way that's not really compatible with the base spec. Because the base spec tells you, for instance, that if you have multiple header field instances and you have an empty header field, it doesn't count in the list. And it also talks about when you are allowed to recombine header fields. And as you are not using the list syntax here, it doesn't really apply. So
I think that can be addressed with prose in the current document, and maybe we can make it clearer on the other side in HTTP ter. But I'm pretty confident.
Last comment from back microphone.
Graham Klein. I was going to make my comment with reference to the discussion about string lengths, but it's probably a more generic comment anyway. Something I find is common use in HTTP headers is conveying URIs, and wonder if that maybe should be a top-level type. Discuss.
So far, we've thought URLs would fit into strings. But if there are use cases where something more specific is necessary, yeah, let's talk about it or raise an issue.
In which case, I would just suggest that the length of this maximum length of a string, take that into account.
Yes. Okay. Fair enough. Thanks, Graham.
Great. Thanks, Mark. Thanks for taking this on. I think we're probably a little bit away from working group last call. We have some feedback to work through there.
We want to make sure that it really works. And yeah, we've gone through it before we put it out there.
So next up is Cache Digest for HTTP2. Kazuho's going to present. Before he presents, I want to let the working group, you can come on up, Kazuho, come join us. Working group know that there's going to be some authorship changes to this document. Kazuho will remain as primary author, and because of the way we have changed the digest format, we're going to remove Mark from the list, and we're going to add Yoav, which reflects the types of filters that are used in their primary contributions in that space. So thank you to Mark for your efforts, and thank you, Yoav, for joining this crazy ship we've got.
So I'd like to talk about two open issues in Cache Digest. And there's actually one more editorial issue pointed out by Julian. Thank you for that, but it's not covered in this presentation. So we now have draft 03, and it has the switch to use Kako hash. And the two open issues are these two. So next slide, please. Yes, the first one is about how we should negotiate the use of Cache Digest. Next, please. So the current approach is to let the client send a indication, and then the server, if it sees the indication, waits for the client to send the Cache Digest before it decides what to push. And on the other hand, the client waits for a server signal which indicates the server's willingness to accept the Cache Digest. And in TLS 1.3, the signal can be sent in the 0.5 RTT flight, so it doesn't cause any delays. And for the resuming sessions, that could be a 0 RTT resumption. A client can remember the signal along with the new session ticket message and use that as a signal. So this is the current model. Next, please. So the issue is that, so we have basically two issues. The server's indication is per connection, whereas in case of a server supporting multiple origins, we might want to make that decision per origin. So is that a good idea? Or in that case, should we use the origin frame in some form to indicate that thing? And the next issue is that should we require the client to cache the signal that the server sends so that it can always determine how or whether if it should send a Cache Digest? So these are the two questions.
Okay. Would anyone like to make a comment? I would if you don't. So I would say that's a fairly significant deviation from what origin frame means, and I'd be more inclined to mint a new frame type for that purpose.
Alessandro Ghedini, Cloudflare. Regarding the first question, I don't think it should be per origin. The indication basically indicates that the server supports cache digests, and that's a per server thing, not per origin, I think. But
let's see.
Thank you.
So, Mike Bishop, I will make the comment that the main case where you want to spell it out is when you have wildcard subdomains. Because if I remember correctly, Origin never did pick up a wildcard, did it?
That's correct.
And so if you're going to have to enumerate to the client all the domains on which you think it could possibly make a request and you'd like to see the digest, even if your cert is star dot whatever, and you don't send an origin frame so the cert stands, you still have to tell it unless we allow a wildcard, or unless you expect it to crawl every domain that it might have cached resources for.
Well, if you're not caching it between connections, it seems like the origin frame is the right match. But if you are caching things beyond the scope of a connection, then it doesn't make sense, I think.
Caching which things?
Caching this information.
Okay.
Yeah. I mean, Origin does have extensibility.
I did not envision that extensibility to be essentially a set of settings with every origin in the frame.
Well, that's an interesting way to put it, because, I mean, we do have Mike West's origin policy thing,
right,
which keeps on limping along, and I've been trying to prod it, but it seems to want to limp. This is yet another case where we say, oh, if we only had that, we could use it, and we don't have it. But when we go and talk about it, we don't have any use cases.
So that's back to your core question of, is this per origin or is this scoped to the connection, right? Because origin frame is clearly, just by its name, scoped to the connection, right? You can have two connections to the same server with different sets of origin frames, and there are very good use cases for doing so.
Yes. And I do suspect that there are going to be cases where you do want to pare down the origins that you send digest for.
Bron Gondwana, I haven't read the spec, I admit, so I'm just listening along and taking notes. But I guess the question here is, what does the client need to know to decide whether to send something back or not? If the server supports handling a request that says here's the digest and handles it correctly, even if it can't use it for a particular origin that it's handling, is that a problem?
No, it's not a problem.
Yeah, so if the server just says, I support this, and then the client sends it and the server can't support it for that particular resource, that's not a problem.
Yeah, it's just wasting a packet or two.
Yeah. Where I'm getting to with this is, it's scoped to whether the server can handle it or not, rather than whether a particular resource can handle it or not. Is my impression, which means it makes sense for it to be a connection rather than a specific origin, because it's the server capability that you're asking for rather than the resource capability.
Right. It seems like maybe a new frame type would be a clean way to do it. I guess get concerned when you cache it between sessions, because then there are a lot of questions about how you scope that, and it's yet another kind of cache.
Right.
Service might be a precedent there. We should explore on the list.
Yeah.
You have, okay, last comment.
Just to add to the complexity of this caching frame, once we have secondary certs, I can envision servers that are authoritative for and want to receive cache digests for multiple hosts, and they need to indicate which hosts they're interested in getting cache digests for, because the browser doesn't necessarily want to send the digest for everything that the server is authoritative for.
Yeah, I think there's agreement on that point. The question is whether origin frame is the right mechanism for doing that. So thanks. Is there another slide? Or
Yes. So there's actually another question, and fortunately it's about removing something. So could you please go to the next slide? So currently we have 4 types of digests, which is a combination of how we calculate the SHA sum, and whether it deals with a freshly cached response or stale cached response. But unfortunately, the only one which is known to work well is for the first row, which is using a URL only to calculate the hash sum, as well as indicating it to show the list of freshly cached objects. All the other patterns have issues related to how HTTP2 is specified, or how it is implemented, or how a server is implemented. Next, please. So, but the fortunate thing is that the first row one is known to work well, and actually your app has gathered some data from HTTP archive, and it shows that the most of the long-term cached resources are actually the most critical ones. So we only need to send a shasam that includes the URL, the key, and for the fresh case. So his proposal is maybe we should remove the other three patterns because it simplifies the draft. So do you have any comments?
Alessandro Ghedini, Cloudflare. I agree that removing would be better. There's also a complication where if you have an HTTP2 stack separate from your cache and you don't really know the E tag, then and the client actually uses the validator's E tag stuff, then you don't really know what to do with it. You're probably just going to ignore it. So agree on removing it.
Thank you.
Okay. Thank you for that update. Looks like we got
last slide. Okay.
No, this was last. Good. Thank you.
Thank you. Thank you. Okay. Moving on, next up is client hints. And we have, again, Ilya couldn't make it. So we have an update from him. So most of the recent activity has been around except CH lifetime and the privacy implications of client hints in general. And so he's saying we converged on client hints delivery is restricted to secure contexts, which is a W3C term. It means basically HTTPS and similar things. Opt-in is origin scoped and by default extends to one-party resources only. First party will have to explicitly delegate permission for third-party origins to opt-in via feature policy. So there's a tie-in now to feature policy, which is a W3C spec. No? Sorry, it's WICG. Thank you very much. So these are breaking with previous implementation. Hints are no longer available over HTTP, and third parties will not receive hints by default. However, client hints usage is currently low, and we believe the potential breakage is low and outweighed by long-term security and privacy benefits. So this spec has been going on for a while. I think it's still baking, but that's where we're at with it right now. Any feedback on client hints?
So Mark, I've heard through the grapevine it might be interested in the variance work. Is that a potential dependency on this roadmap?
I don't think, I haven't looked at it in a little while. They used to describe how to use it with key, or at least in reference key. I think that's been taken out. I think they're waiting for variants to be adopted, or at least for its future to be clarified before they take any further steps. I have talked to Ilya extensively about client hints and variants to make sure it meets his use cases, though.
Okay. Back microphone.
Nick Doty, UC Berkeley. I agree with these changes. I think as it's noted, there's potential increased benefits over the previous drafts for privacy and security. So great work. I am still a little bit confused about just sort of the status and direction. Sometimes in the group, it seems like this is just for DPR and client width. And then other times it's like, hey, we could put anything into a client hint. And we'll start sending geolocation lat long in these headers. And there's a big difference in what kind of review we need to do, or like how we can consider all the implications based on what kind of data is going to go through there.
So the current draft contains all the hints that we're talking about now. People do raise issues in the repo to say, oh, we'd like this one. We've so far shied away from adding more ones without a lot of process around that. And I think while client hints is considered to be a framework, in other words, it's something that you can add new ones to later, I think the expectation is that you'd have similar security and privacy review before you actually consider adding them.
Okay, great. And the other question is the lifetime idea is a little bit unusual, like compared to, like in some ways we're analogizing to JavaScript web browser permission interaction. And in that case, like sites don't indicate how long they want permissions for. Yeah, maybe they should, or like.
Sorry, what was the comment?
Maybe they should, yes.
Maybe they should, okay.
Yeah, or maybe there should be a chance to revoke it. It just seemed like we just kind of threw it in there, and like there's just a couple of shoulds in there, and I wasn't sure like what is this how we're going to do permissions now? It seems like that should be more coordinated.
It's an interesting point, Martin.
Yeah, so Martin Thompson, that's a great point. I like that. I actually don't like the lifetime thing, but considered myself to be in the minority, and so I'd be okay with removing it if that's where people want to go. But that's not what I got up here to say. These changes that you see on the slide are not the changes that made me slightly more happy with the privacy properties of the protocol. These don't actually change things materially at all. The properties that made me more happy was the more robust text around the sort of considerations you might apply when you decide to start sending one of these things and under what conditions you might send them. And so there's a ton of that in the draft now. I won't say that I'm 100% happy, but it's much, much better than it used to be. Part of the reason that text was added was in response to comments about geolocation. I would be vehemently opposed to anyone putting geolocation in this one, with no matter how much text you put in there, because we simply don't understand how to control that sort of information. And it's very different to the sort of things that the current draft concentrates on. So just setting some expectations there. If someone tries to put something in here, and then really what we're talking about is defining a new HTTP header field that leaks private information about users at this layer, then we assess that on its own merits. And this just gives us a little bit more text that allows us to deal with those sorts of things and maybe explain to people the sort of things that you need to consider when you go into that. It's kind of odd because we haven't had that in the past, but this is a valuable exercise, I think.
Sure. And we'll make Ecker the last comment on this draft.
Oh, great, good. So it seems like this condition 3 cuts in two directions, right? So on the one hand, if you can store cookies and run JavaScript, then you can extract this information and just shove it in a cookie somewhere. And so it's not clear what this does. On the other hand, for privacy, on the other hand, if you can extract this information and with store cookies and run JavaScript, then why do we need the header? So I think and so I guess that's where I'm getting a little puzzled. It seems to me the only difference is for the first hit, right? Am I missing something important? I don't know. I mean, I'm not trying to just drop that and leave, but I don't know how I proceed here because I'm just trying to figure it out.
The queue is closed. If you can directly answer the question without extending the thread, go ahead. Otherwise, mailing lists are available.
Preload scanner. Preload scanner. You don't get a crack at it in JavaScript. The preload scanner executes fetches about content in the document well before JavaScript executes. So potentially the requests may be fetched in a way that the server will want to accommodate without the document having had a chance to modify the outbound request in the first place.
And in particular, viewport width and width of the image.
Okay. It sounds like maybe this is an offline discussion. Yeah. Okay. Thanks. We're not going to take this to working group last call terribly soon, so there's still opportunity to discuss it.
Speaking of drafts that have been with us for a while and aren't going to working group last call very soon, we have an update on the cookies work.
So I don't have an update from Mike on the cookie spec, but I did have another photo from London, which I liked. So we've been doing cookies for a while. I know that he's incorporated at least some of the drafts. So we're hoping to close this down relatively soon, but we understand that there are other things that are happening as well. So we don't really have an update per se, but hopefully we'll be able to wind that up in the near future.
Anyway, we have discussed this, and we think it's moving, if slowly, and it's worth the working group continuing to pay attention to. So next up we have HTTP tray. Is this still in? No, we're going to talk about
I'm so sorry.
related
I'm
work
so sorry.
first.
You're absolutely right. Signed exchanges. So Jeffrey.
So this is explicitly in related work that we think the working group will find interesting, but this is not something we think is at a stage where we're going to ask for adoption based on this discussion.
Right. So this is mostly a heads up and an introductory discussion. We've given it 20 minutes, so let's try not to go too much past.
So I believe 10 and 10 is the plan.
So I'm Jeffrey Yaskin. I've been working on origin signed exchanges. This was introduced at Dispatch in Prague as web packaging, but they and Mark suggested that I split it in half, and that HTTP would be interested in this half. So let's go to the next slide. There's a collection of use cases. The one that's currently justifying a lot of investment from Google is something we're calling privacy preserving prefetch, which along with some other changes that other people are working on, lets Google search treat AMP and non-AMP content the same, which should help with a lot of the hatred toward AMP. Another use case is avoiding the slashdot effect. So if you've got a popular website that links to a small website's content, you might be able to use an origin signed exchange to avoid knocking over that website. I should step back. An origin signed exchange is a representation of an HTTP exchange, so a request response pair that is signed as an origin. And then a browser could trust that it actually came from that origin. So that has some interesting security properties that we're going to talk about later. They can also be potentially used to evade censorship, since the signed exchange could be delivered from a server that is not the one that your ISP or government is blocking. This has the other effect that it can be used to evade legitimate filtering, so we have to trade that off. There's a potential use case that to push content from other CDNs. I don't know how to actually do this in a privacy-preserving way, but if people can figure it out, the CDNs are very excited. And you can do it if you don't care about caching. And then the original goal for all of this work, which doesn't work yet with just origin signed exchanges, is to be able to share whole websites peer-to-peer while you don't have any connection to the internet. So this helps with developing countries or people with very expensive data plans. Next slide. The basic structure here is you have an HTTP exchange. We define a new signature header, which signs a collection of things. It identifies a certificate chain and gives the hash of the certificate you expect to find there. That's a URL rather than just embedded, because you might have the same certificates for several different signed exchanges. It gives a validity range, which is currently limited to 7 days to match the OCSP validity window. It gives you a URL that you can use to update the signature so that you can get a new signature at the end of that validity range without re-downloading the entire exchange. It identifies a header that guards the payload's integrity. For the initial implementation, that's Martin Thompson's MI header, the Merkle integrity encoding. But it could be other ones in the future. And then you actually sign using the certificate's public key, a concatenation of a subset of those things that we think are important to make sure are authentic. We define 3 ways to transfer these signatures. You can use a normal HTTP header in a normal response. for a same origin signed exchange. You can use HTTP push to push a request response pair that might be cross origin. And we're defining a file format that wraps the envelope and can be downloaded in a streaming way, which is what the initial implementation that AMP is going to use will use. Next slide. We believe that privacy is just about the same as what you currently get over HTTPS. This is surprising because a signature provides authenticity but not confidentiality. But the reasoning is that someone who's trying to get a victim's private information has to give them the link to the signed exchange. And so they know the link that someone's following, and link tracking is a thing. They can follow a redirect series or just use JavaScript to know that someone clicked on an exchange. If we were to add a feature to discover exchanges through some side channel, that would break this property. So we shouldn't do that. There is one change compared to HTTPS. The link source can guarantee the target's content instead of just being pretty sure it's what the link source retrieved from the target server. It's a question whether this matters. I don't think it does. Next slide. A bunch of architectural risks have been raised. So unlike something in a client's HTTP cache, if a user can load a signed exchange without ever connecting to the origin server. Now the signed exchange can then, if it can execute JavaScript, it can ping the origin server and say, hey, I've been fetched. If it's just an image, it can't. This is very similar to old HTTP non-TLS caching proxies. People pay CDNs to do this, but there's a question of whether whether it should be possible to opt in by signing an exchange to someone you didn't hire to cache your content. It's a totally new proxy model. So we've had normal proxies that are configured by the browser, configured kind of globally. There are reverse proxies that are configured by the target server. This one is configured by the source of a link. Is this an important change? And then there's a worry that this privileges large sites like Google that can run their own caches. Now CDNs can provide caches for smaller sites and can promise to preserve privacy in fetches. But there's a question of who this helps on the internet and who will be able to take advantage of it. Next slide. There's a bunch of security risks. So all the risks with certificate frame also apply to signed exchanges. It is possible to replay messages to clients. So 0RTT in TLS 1.3 and session resumption let you replay requests. This allows you to replay responses. There's some defenses against the attacks that opens up in the draft, but there are also other things like JavaScript setting cookies that we can't just block. So a server has to be aware of that when they're deciding to sign an exchange. It allows downgrade attacks within the signature's validity window. So if a server finds an XSS exploit in their JavaScript, upgrades the JavaScript, pushes out a new website, an attacker can notice the change in the website, take their cached signed exchange and send it to victims. So this was already possible if a user caches vulnerable JavaScript, but now the attacker can force the victim onto the vulnerable JavaScript. And finally, if you expose a signing oracle, so you don't lose your key, but you give people the ability to sign things with it, then they could sign future packages. There's currently no trusted way of establishing the date that a package was signed. Next slide. So we mitigate these in a couple ways. To prevent replay attacks from being a problem, we block authentication headers. We advise servers to, if they decide to sign an exchange, they shouldn't use any authentication information when they're producing the response. We think that signing things that are cache control public is safe, although we don't have clients enforce that yet. If people think it's important, we could. Downgrade attacks are limited to 7 days. The validity window is a trade-off. People could have opinions that we should make it bigger or smaller. And there's a way to refetch signatures. So a client that wants to check if it's being downgraded could fetch that from the server directly from the origin server. Signing oracles are defended against by requiring a new X509 extension so that you can't use a TLS signing key as the signing key of for a package. So you have to at least claim that you don't have a signing oracle in order to sign a package. We could protect the date, but we currently don't.
I'd like to hold questions if we could at all.
A clarification question, if it's possible. So you said that the signature validity is capped, but you also said that you have no idea when it was, no reliable way of saying when it was signed. How did those?
Right. So the date range, the begin date to end date is 7 days, but it is possible to sign one that's valid, that starts being valid a year from now and is valid until a year and 7 days from now.
Okay.
Next slide. So Chrome is currently implementing this. We're doing a subset of the draft, and I've kind of copied and subsetted the draft into a new draft that we can use for versioning. I'm interested in opinions from this room about whether that's the right way to do kind of snapshots for implementation, for matching implementations. We're working with Google Search, Baidu, AMP, and a couple publishers to try to prefetch both AMP and non-AMP signed exchanges from the search results page. So right now, Google Search prefetches AMP content from the AMP cache when you get it in a search result. This allows us to preserve the URL and prefetch also non-AMP content. And so we're trying to demo that around May. We're hoping to find another hub kind of website or just produce a kind of a demo, something like Reddit or Hacker News that could also prefetch their link targets, either to preserve privacy but still prefetch, or to avoid the slash shot effect. And then if all of this goes well, we're hoping to run an origin trial late this year. And an origin trial allows any website to opt in to producing signed exchanges and hosting them. I think this is the last slide. So go to the next one, and it should say.
Is there another slide?
Yeah, sorry. Next slide.
Wrong window.
Yep. Okay.
Oh.
That's all.
And you did a good job of hitting the clock, so we have 10 minutes for discussion.
Yep.
So Roy Fielding, I think this is a great idea, but I absolutely terribly hate the notion of a 7-day validity window. I mean, just with a passion.
Do you want it bigger or smaller?
Unconstrained entirely. I see no reason for a validity window at all. If you're concerned about changes in JavaScript might indicate a bug, just require it not be used in that case. Require that the identifier be changed for that particular type of resource. It's the value of being able to sign public documents that are not JavaScript far exceeds, for the sake of privacy, it far exceeds the concern of that you described.
Thanks.
Lucas Pardew, BBC R&D. So I've had a skim through this spec, and you mentioned Cabbage signatures, but you both define the signature header. So that's a clash, albeit on a document that's not a thing.
Absolutely. We will. I don't expect the IETF to standardize both of those topics. It will pick one. So there's not a real clash. Mm-hmm. If you go 2 slides later, I have a comparison of Cabbage signatures with this proposal. Sorry, go again. There.
Do we have an understanding of how widespread Cabbage signatures might be in the real world?
I do not. Okay. If anyone can tell me, I'm happy to include that somewhere.
My impression is it's used mostly by some APIs, so backend or non-browser APIs. That's my impression.
Okay, thank you.
Eric Scorla. So I mean, first, thanks for attempting to ameliorate some of the horrifying security properties of this proposal, so they're somewhat less horrifying. I have two underlying concerns of this proposal, one of which I suppose is technical, and one of which I suppose is more philosophical. The technical one is I spent a bunch of time trying to reason about the security properties of this, and I still can't. And you know, that makes me very uncomfortable. You know, certainly lots of terrible things can happen if people are not careful about the way they've managed their headers. So, you know, having something which is a statically signed object appearing in the origin is quite concerning. As I say, we could probably work through those issues in the case of SRI caching, or basically same origin signatures. The origin substitution feature strikes me as something which is unnecessary for a large number of use cases I think the IETF should care about, and is toxic for the use cases which I think the IETF probably shouldn't be endorsing. So if we were to adopt this, I think we should really focus on the cases that do not involve origin substitution and see how that goes. And then we can discuss origin substitution at some later time.
For clarity, this working group is not considering adoption of this document.
Oh, okay. Then thank you for your contribution. It's very interesting.
Paul van der Rooshaven, Global Sign. You mentioning a 7-day window for the validity, linking that to the OCSP status of the certificate. I'm not sure, did you have in mind to make that a static window? Because responses, 7 days is a maximum defined by CAP Forum. Actually, most CAs make that window shorter, and well, we even get often requests to make it even shorter. And you also have a cache period, so a request could be valid for, well, a couple of days maybe only.
Yes, the 7 days is just kind of a first guess at what the right maximum length is. We had a request to make it longer. We have a possible request to make it shorter. For the cache headers that interact with the signature length, we think that we will stop trusting something at the shorter of the two lengths. Depending on which one expired, we might refresh it in different ways that we're still kind of working out.
Okay.
Ben Schwartz. So you mentioned potentially having more aggressive verification or more aggressive checking. I was wondering if you could talk just a little bit about what possibilities you see there. Off the top of my head, it seems like you could imagine something like static content essentially is valid immediately, but either maybe JavaScript can't run until after the signature is verified online, or JavaScript can run, but the page doesn't have an origin until the signature is verified, so it doesn't have access to the origin. If you maybe there's some variation in there that would balance them.
Those are possible. We haven't figured out exactly when browsers should fetch the validity URL to double check. The idea of giving it no origin or putting it in a unique origin until it's verified is difficult if it calls APIs that access storage. Because then you kind of have to swap out its storage underneath it, which can lose data. There might be ways to do it.
Or possibly hang until until fetch completes.
Nick Doe, UC Berkeley. I like how careful you're being in describing the security properties and the list of headers that might indicate that this is stateful. I'm curious though, like what should a server do? Like assuming servers screw up, which I feel like is a safe assumption. What should a server do after they screw up? After they sign something that was stateful but somehow got through those checks, how would they unscrew up?
Right. So I haven't thought through that the whole way. Clearly, they should stop signing new ones, and the old ones will eventually expire. If they think their users have been forced into an attacker's session, for instance, they can use the clear site data header to clear everything. They can probably also set different cookies. Like if they notice a particular attacker is taking advantage of it, they could notice those cookies and reset them. There may be other mitigations.
Wait, can they use the ClearSight data? I thought the whole point was that they were it's going to be delivered cached. Like they can't update the JavaScript.
Right. So once the signatures, so the people are broken for that 7 days, or for whatever signature validity they set. After that, the clients have to go back to the server or get a new signed exchange.
Okay, thanks.
I also want to mention that we had a side meeting yesterday at which we talked about web packaging in general, and the agreement there was that we're going to hold a workshop to try to get more publishers to weigh in on the ecosystem effects that I know Martin and Eric are worried about. It will be organized via the TAG and the IAB. I don't know exactly when it will be.
That was a notion there. I'm not sure it's that solid yet.
Okay.
That was one of the things discussed. Yeah, and so that's it for.
That's it for this.
Okay, so thank you for that. That's very good. Like Patrick said, we're not considering adopting this now. That doesn't mean that will not ever change. So I'd encourage you to continue talking to folks, both here and on the list. And if folks have concerns or they support this or whatever, it'd be great to hear about that. So thank you very much.
Thanks.
However, our next set of items are things that we think are ripe for the working group to consider adoption on. The first one is HTTP TER. We talked about this in Singapore. And before this presentation starts, I just want to sort of set the stage a little bit. You know, I've been instructed that I'm supposed to pronounce that TER.
There's a lot of disagreement here, so.
I'm going to move on from that bike shed. We'll take that one to the list. That ought to be a great place to work through pronunciations. In any event, you know, the discussion we had in Singapore and a little bit on the list scopes this as a statement of essentially the HTTP semantic layer as being the most important revision of the 7230 series of documents that we all know and love, and that 7540 refers to the semantic bits of, even though no one's exactly sure where those are defined. And so that's one possible very important outcome of this work. There are others. If we do choose to adopt this work, I've asked Julian, Mark, and Roy, all who worked on the first set of, well, they weren't the first set, but the last restatement of HTTP, the BIS.
Fifth set.
To be editors on all the documents that may be output from this effort. And the question of how many documents I'm sure will come up. But so that's my introduction. And Julian, you going to drive this, or is Mark going to drive this? Roy going to drive this?
Roy, what do you do?
Come join us on the
I
stage.
did the last one, so somebody else does this one.
So we have 20 minutes. Be great if you left some room for, you know, some discussion.
So as luck would have it, the Apache members meeting started exactly the same time as this. So I just okay. So we've got this notion that we're going to revise HB 1.1 one more time and finished, absolutely be finished. So go to the next slide. Yeah. Julian, you want to describe the history?
Yeah, so that was just a reminder how we got here. Between 2016 and the revision, we had a gap of 8 years. We finished the revision in 2014, so it's already 4 years if we start now. So it's not like it was yesterday that we finished. Next slide. People sometimes ask, why do you want to update? So we can't change the RFCs that are published. We collect errata, but people do not look at the errata. When to update, depending on how much we want to do, it will be something like 5 years since the last revision, which isn't that quick. So I think it's the right time to start work on it. And also, we might actually hit the point of time where the RFC editor starts publishing documents in HTML format so people can actually look at a readable spec. Next slide. So we took the original Subversion repository that contained the work on HTTP-BIS and did a few minimal edits like renaming the documents, updating the obsolete relations, updating the acknowledgements and so on, and have published the first set of drafts as non-working group drafts for people to actually look at how that would look like with these minimal edits. And the last link in each line has the diffs from the published RFC. And those diffs essentially are totally editorial with the additional bit that as we changed XML to RFC versions, there's a difference in hyphenation of terms. So don't worry about that. That's an artifact of the XML to RFC version.
Yeah, the only real changes are places where the existing RFCs refer back to the prior RFCs 2616. We're changing those. We changed that to refer to the RFC 72, 30, 31, etc. And we took out the history sections that are referring back to previous RFCs as well. So other than that, it's all exactly the same. The only mechanical difference is really that RFC 2H XML to RFC. Some of which are bugs which have already been fixed in XML to RFC.
There's one more thing. We took out the term HTTP 1.1 out of almost all document titles, realizing that only the first spec actually defines the 1.1 format, while the other specs are supposed to apply to all of HTTP. Next slide. Okay, scope discussion. So the obvious things to do is applying errata, updating references, trying to resolve the issues that have been collected on GitHub. And the number of these issues went up from 30 to 50 between IETF 99 until today, which is a good sign. And minimally, we need to say that there's also HTTP2 and where to find it. So that's something that absolutely needs to be done. So that's why I called it the obvious scope. Next slide. Less obvious is, do we reorganize our specs once again? Trying to come up with one document that is specific to the wire format, and having the right hooks for HTTP2. Then the other discussion is, was the number of 6 specs the right number, or should we try to recombine stuff again? Less obvious things are also satellite specs that were published later, but where we felt that in theory that should have been part of the specs already, like the missing status code for permanent redirects without method name rewriting, to authentication headers that we lost and re-added in 7615. Some extensions to content encoding negotiation. I had a spec describing how a server would tell a client which content encodings it would accept. And we had recently another request for servers to be able to specify which media types in a request they would accept. So that could also go there. I also mentioned random access because at some point we thought that this was just a clarification or slight extension of the range model. I'm not sure where we stand with respect to that right now. And mechanically, it should be a goal to actually move HTTP to full IETF standard, but depending on how much other things we want to change, that might not be possible. So
Yeah, I mean, certainly my intention and goal would be to not make any technical changes that would cause it not to be the standard. Go to full standard, just because there's really no reason after this to revise it again. And if we don't have a full standard for HTTP, it's kind of stupid. Because there are many times in which people have asked us to move it to full standard, even with known problems. Whereas we can actually fix all the known problems and just move it at that point. Martin?
Yeah, Martin Thompson. You just hit one of my hot buttons, sorry. And I stood up anyway, even realizing that. So I actually think that some of these at least are great candidates for inclusion in these documents. That doesn't necessarily conflict with your goal of going to full standard. I personally don't think that the value of full standard merits special attention from us. So if we decide that something in here needs to go in there, it should just go in there, and we proceed otherwise. It is our responsibility to maintain documents, not necessarily strive for perfection, because we know how well that works in practice. I've written a few things on this topic if people would like to read about that.
Yeah, I'd agree with that. With a separate, a slight extension, we do have a responsibility to communities outside of just the IETF, in that they rely on us to provide something that we consider to be a standard, so that we consider to be a standard can reference it at the same level. I mean, the IETF has that notion internally. There's also other organizations like ISO that have that notion as well. So there is some desire outside of ourselves just to call it the standard, even if it were revised 5 years from now. Yeah.
Next slide.
So I put together a few points that we actually should try to decide upon today. Like, do we want to do this? Do we start with what Roy and I submitted a few weeks ago? Think about how this affects the HTTP quick document, how these can evolve together, whether there's actually some dependency in one direction, and what that means timing-wise. Decide on what we are allowed to change, document organization-wise. Yeah, and technical bits.
So thank you for that. I would actually like to clarify mostly what you've put up on these slides, which is great. So if people have comments specifically about the timeline in relation to the quick work and the quick working group, and whether or not we think that would impact this document, which is not obvious that it would. And also, can you go to the, I do want Mike's comments there, but can you go to the previous slide? Also, the bullet here about split information specific exclusively to HTTP1 into a separate document and relabel everything else just HTTP. I call this the mysterious semantic layer of calling it out. And I will make a chair comment that I think our ecosystem badly needs that contribution. So I would want that to be in scope personally. I have individual contributor comments on some of the other things, but I'm happy to open the mics on these particular questions.
And then from my perspective, whatever hat I'm wearing, I think that's the most important thing to do, to be honest.
So Mike Bishop, a couple different hats in hand. As the author of the semantic layer draft, yes, please, I would love to see this in the spec. It would make things a lot cleaner. As the editor for HTTP over quick, yes, please, it would make referencing HTTP separate from 1.1 and separate from HTTP 2 so much easier. And then there's the timeline. That if we actually want the quick docs to be done by the end of this year, this isn't going to be done by the end of this year. And so we're going to have to sort out, I assume we don't want to hold HTTP over quick for this. But then that would mean you're going to immediately replace what I'm referencing with something better to reference.
So that's not a decision of this working group, the issue be over quick, but I would agree.
So just I'll respond to that. I think, first of all, with my quick hat on, the intention is to have the technical work done at the end of the year. There may still be some baking after that. Having said that, I intend to put a fair amount of energy into this, and I'd really like to get it done quickly. I do not want to spend 5 years doing this. I'd like to spend less than a year doing it. I don't know how you guys feel.
Right, I agree with Mark. I mean, it sounds like an open-ended problem, but it really isn't in terms of specification work. Particularly once we decide how many drafts we have. Right. Once we decide how many drafts we're working on, then it's just a matter of squeezing them into the right spaces. What we have right now, we already have the text. We don't have to write new text. So it's squeezing them into the right space, which I could do this week. And then going through the set of issues that have been refined already for the previous one, which is again, that's not going to take the editor as much time. It may take the working group more time to figure out if we have working group consensus.
Okay.
But I would be utterly shocked if we did not finish before quick.
Yeah.
Even reach technical agreement. So
This took a long time because 2616 was in a pretty bad state, and we had to work through a lot of issues to clarify things and figure out where we laid on, the interrupt was really bad. That's not the case now. We're working with a much more mature document set.
Okay.
If we do say so ourselves.
Yeah, I was going off the bullet on one of the previous slides that said this wouldn't be done before 2019 at the earliest.
Sure.
That being said, schedule risk is something, everyone's going to assess for themselves. And part of the schedule risk is going to be the engagement of the working group, as you mentioned, whether, they're going to be able to help progress these documents and get the reviews done. So before we get to the adoption questions, I'm just interested maybe in a show of hands of people who feel that they would be willing to be, involved in reading these documents and helping push the process forward. 23. So maybe 15 for the minutes. Okay. Thank you.
Can I actually?
One more slide, I think.
Oh yeah.
Right.
We have time.
Yeah. Not more slides. Just go back to this. We were actually talking about splitting up the document, and we've talked about this various times. I mean, the history behind it. We split at the beginning of the previous revision process. I split up the document 2616 into 7 parts, mostly so that we could assign different editors to different parts. And do things in parallel. But it turned out that we didn't actually go that way. We did all the documents in sequence together, and there wasn't really that need to split them out. It was useful, however, to isolate the issues. In this case, my personal feeling right now is that we could move all the semantics documents into one document, move the HTTP architecture from what's currently part 1 of the messages into the semantics document. And so have one HTTP semantics document, one HTTP cache document, and one HTTP messaging document. And that would be it. So we'd end up with 3 documents. The other alternative would be to move everything into one document, and just for the sake of referencing that one document.
Sorry, Roy, when you say messaging, did you mean HTTP 1.1
Right,
there?
1.1.
Okay, so 1.1 semantics and caching.
All right, so there would be one document that was specific only to HTTP 1.1, and the other 2, cache and semantics, would be the not 1.1 specific.
Where would validation end up?
Validation?
Conditional requests.
Well, conditional requests would be in the semantics.
Not caching.
Cache would be in, how the caches would use those semantics would be in the cache document.
So that would still be a reference.
Yes.
Okay.
Yeah, there's definitely be a reference from cache.
Like it is now.
Right now. So does anyone have any horror or alternative ideas or preference for one way or the other?
Brett Jordan, please, fewer documents.
So that's
fewer documents means more pages.
Desire for fewer documents, but not an absolute requirement of one.
If we're going to try and go do a full standard for this, then yes, one. But fewer documents is better than trying to find everything because it is really a nightmare right now.
So I would describe a certain tension there between when you have a smaller granularity, right? It allows us to revise documents. I know we don't want to do this again, but you know, it's not implausible that we would. Allows us to revise them independently, and so that's from a process point of view. I think that's really the strongest argument that resonates with me for multiple documents. You know, as an engineer who's worked with these things for a number of years, I'm on board with the less, please. I would actually make an argument for 2. Semantics and H1.
So no separate cache document?
I don't think it stands out as especially different than.
I think the one thing about it is it's longish and it is targeted at a separate implementer.
Right. That's the only really thing.
Right.
So that's fine with me too. 2 is great.
1 doesn't make sense to me. 2 makes sense to me. 3 makes sense to me. So.
Does anyone else have a comment on that? I'm not sure it is targeted at a completely separate implementer a lot of the time.
Not for you, of course. All right.
Okay.
If I were chairing this section, I'd say that ultimately it's an editorial decision that should be made by the editors in consultation with the working group. So I don't know if that we need to get consensus on it, but input is appreciated.
Input is appreciated. And I did actually, we're going to talk about, you know, having a hum to adopt it. I wanted to get a sense of the scope of where we were going, but I do agree that, you know, the details, you know, are what the consensus of working groups are made of, and we'll make that happen, you know, after adoption. I think that's fine. So are there any other comments that would like to be made before we hum? We've had a 2-hour meeting without a hum. Okay. So if you favor the working group taking on this work, specifically to include the semantic layer represented on this slide by Bishop decomposing HTTP, though not necessarily that text, and you favor expressing that in a smaller number of documents than we currently have, you will hum for the first option, and the second option is not to adopt this work at this time. And if we end up there and there is an alternative, I guess we will explore those paths. Okay. So option 1, which is for adoption, please hum now. And option 2, to seek another path, hum now. Oh, that's great.
Very clear.
All right, we are headed for HTTP tray/tur. Thank y'all.
Get on the tray-tur train. Okay.
All right, we have. Oh God, a new meme has begun.
One question I should ask: do you want us to stay in the repo that I set up now, which is just in my private repo space?
I was thinking we could shift it over and blow away the contents of the BIS repo and maybe rename it, because then we preserve the issues list.
I didn't know we could blow it away, but
we can blow it away.
I think we'll huddle and send the results of
we'll
sort it out. I think that's the best way to do that.
Okay, thank you. Next up is S&I in alt services. Actually, it's really an alt services focused presentation. If I can find myself here. Where did my folder go? No.
We got 23 minutes.
We're doing okay. My computer is very confused. Excuse me for a second here.
Sure.
It turns out it is.
Oh, it's gotten confused about where the bar is, right? Okay, sorry. Oh, crap. It goes to the lower one, right? Okay. Now. Not the bottom one. You're not a Mac user. There you go.
All right, so we're talking about keeping the data leakage down from putting the host that you're trying to talk to into your TLS handshake. I imagine if you've come to an IETF before, you've probably heard a session on this because it's a topic that keeps coming up. And it's a hard problem. Next slide. So in a lot of ways, encrypted SNI has been kind of the holy grail. It's something that we'd really like to do in TLS, and there have been some interesting proposals of ways to do that. I think, is it Thursday that we're going to talk about the tunneling TLS in TLS proposal? I remember another talk where we could use the handshake keys for 0RTT to instead put the SNI and the 1RTT flight. And there are lots of ways to approach this. And it's because host names are interesting. They disclose some information about the person who's trying to visit the site, or about what their interests are or what their plans are. And we would like ways to avoid leaking that data where we can. And there are lots of places where that information leaks. Another one is DNS, but SNI is an obvious place that people look for, and it's a hole that we can plug. Next slide. So the reality of the Holy Grail is a little more complicated than that, because the servers do need to have the SNI data to figure out what cert to give you. There's a lot of routing that goes on based on the SNI header. And even if you were to encrypt the SNI prior to TLS 1.3, you could just see what certificate came back. So TLS helps with that, but an active attacker can get the certificate anyway because they just connect to the same site and send the same thing you did. If they can replay it and see what the response was, that helps. Next slide. So we're trying to plug a lot of holes here in getting this to be more private. DNS gives you the host name. We have DO to help with that. SNI leaks it in the client hello. Well, we can use secondary search to help with some of that. In that if you can open a connection and then once you have the encrypted context, then say what host name you're actually interested in and get the cert undercover, that improves the privacy properties there. But that requires the client to have some kind of innocuous host name that it can present in the actual handshake that will still get it a valid cert. So the piece that we're proposing to address that is to extend alt service to allow you to specify, here's the alternative I want you to use, and when you connect, ask for this host name in the TLS handshake. And then you might get back a certificate that covers both host names. You might get back a certificate that's just valid for the one you asked for, and you need to use secondary certs. But either way, it gives you a path to actually approach an alternative with a more innocuous name that is visible on the wire. But as Martin pointed out when I sent that draft out, there's a bootstrapping problem in that you still have to have talked to that host before to get the alt service record. And so this idea has been around a lot of times, but I don't think actually been written up, that you can put alt service in DNS. And circling back to DO again, just there's a way that you can get DNS records without leaking them on the wire. Next slide. So we've got a couple scenarios here that we'd like to make work. One of the easiest ones to deal with is if the host has many domains, only some of which are sensitive. You're on the same server, so you've got all the certs right there. It's even more interesting if you have a wildcard cert, that if you have a certificate for star.example.com, then you can effectively conceal every subdomain that you have just by telling clients that they should connect asking for www.example.com or even _wildcard. Just pick something that is not going to give away what your real destination is. And it's important to note that you still need the clients to validate. The first version of this draft said that the client could completely ignore what was in the TLS handshake and just ask for the real one. But the failure with that is that then you have an active attacker problem, that an active attacker could catch your TLS handshake, man in the middle, and then see what secondary cert request you made. So you have to check that there is a real server-owned cert there first. So probably you still need 1RTT to achieve this. If you know that the certificate before covered both domains, then you can do 0RTT in that case. Next slide.
I'm just trying to work through that, Mike, if you don't mind. So Can you scroll back to the previous slide?
Sure.
So the setting here for the zero round trip case is I connect to, as you say, start at github.io.
Mm-hmm.
And then separately, so I've got like I've got a PSK established, and then like sometime later I want to go to CIA.gov, and I do alt service. I do a name resolution that gives me alt service, and then I go and it says, congratulations, it says start at github.io, and then and then what I do is I say, well, I already have that PSK, so I'm going to do zero round trip. Is that the reasoning?
Not quite.
Okay, yeah, please help.
So in the case where you could do zero round trip is, I saw the cert before.
Yes.
The cert covered start.github.io. So I will do SNI for something.github.io and then send a request for something else.
Oh, sorry. So I do the cert says start.github.io and I resolve for CIA.github.io, and then it says you could do any start, you could go to innocuous.github.io, and then I already have all that crap in cache, so I just zero round trip.
Right.
Okay, thank you. I'm not entirely sure I love that, but I think it's okay.
So the SNI extension is really simple. It's just one more parameter on the alt service record that says what SNI you suggest the client should use. And since alt service extensions are optional to understand, if a client doesn't understand this, then they'll just go use the alternative like normal. They don't get the privacy benefits, but it should still be a valid alternative. The one departure from it being a host name is the draft currently defines double quote to indicate don't use SNI. Just omit the extension. Some people like that, some people don't. Up for discussion. And then next slide. Ben's draft takes an alt service record, drops it in DNS so that you can go do a lookup for it and then just have it without ever having spoken to the host before. So that helps deal with the bootstrapping problem where you have to connect in the clear at least once. It also gives you some nice collateral benefits like being able to do HTTP over quick or opportunistic encryption without having to do the clear text or TCP path first. And is there one more?
Questions?
Nope.
So it's back there.
Yes, co-author is joining me.
So I have a question. So I'm generally sympathetic, and I think this is good work. Alternate Services has a couple things to say about SNI. I'm wondering if we think this dovetails with that, or we need to update alternative services. It says that client must not use a TLS-based alternative service unless the client supports SNI. Note that the SNI information provided in TLS by the client will be that of the origin, not the alternative, as will the host HTTP header field value.
I'm not sure whether that requires an update or not.
Yeah, me either.
Something to consider.
Food for thought.
Yeah.
Kyle Neckritz. Is your intent with this to be something that could be widely deployed and used on a large amount of traffic, or just something that specific clients that really care about privacy and are willing to take a performance hit for that should do?
I think the alt service and DNS piece of it could actually be a performance win. And so I would expect that to be done very broadly because you have the potential to step up to quick or HTTP2 on an alternative or an alternative that's closer to you. Hiding your SNI, you may or may not be able to do zero round trip. And so I think it's going to be an implementation dependent choice, whether you value more consistent zero RTT usage versus sometimes paying the extra round trip to hide your SNI.
So the issue with a SNI value in DNS that you send and get the proper certificate is that SNI can be replayed, and someone else gets the certificate that will expose the actual site you're connecting to. There's ways around that if you can give a key that you mix into the TLS connection as well, but that's more modification into the TLS layer.
Yeah, so I think we cover both cases. If you can do this, if you can get the certificate you need without disclosing any information and without an additional round trip, then that is what will happen. And if that is not possible, then you will get the wrong certificate, which does not disclose what you're trying to hide, and the client will pay an extra round trip in order to get the certificate that it actually wants.
We're going to have to cut the lines after. The people who are in line are fine.
Definitely, just to the host header point, it has been a while since I looked at these deployments, but at least a few years back, there were deployments where the SNI check was used to make sure that they were in the correct set of cryptographic context, but the host header was still being used to steer to one or more servers which were behind a load balancer. So I would imagine that we would have to look at that to make sure that it was okay for us to make sure that they changed in lockstep, which I think totally makes sense given what you're doing here. But I think that the language of the current alt service draft might need a minor tweak to make that no longer forbidden by the spec.
So, yeah, so right now what happens is you will use an alt service to discover an alternative for one, and then based on the certificate, you'll discover that I can also make requests for other things, and on those subsequent requests, the host header will be different from the SNI.
So I was actually thinking about it in particular in the use for like the alt service records in the DNS case where you haven't gone and gotten the alt service from the thing directly yourself. But I'll have to think through it a little more. But I do suspect that either modern practice has already moved away from the spec or we're about to.
Martin Thompson, a very brief comment. Acme are looking at using SNI for validating ownership of domains. This would be a landmine for them, so we'd have to be a little bit careful with that. And the other one was, what's the relationship between the expiration time that you have in the record here and the RR set? Things to think about, not to respond to. Just consider those things.
Well, okay, I'm responding anyway to say the draft does.
We are time constrained.
The draft does say they must match.
So just thinking at what Ted said, so it's already the case that host header and SNI can mismatch because that's what TCP connection coalescence requires. And it's not, in fact, I haven't read the spec in a while, but it's not even clear to me that the first request has to match the SNI. Like say I connect to, I want to fetch I'm trying to fetch, from A.com and B.com, and I erase the connections and then I connect it, but the B.com is higher priority. And so I connect to A.com, discover those certificates for A.com and B.com. I think I can just shove the B.com connection right away if I want to, right? So, so it's already the case that those don't have to match. I think it'd be really good. Christian Wiedemann did a really nice job of trying to map out the entire threat model space. And I have to admit, I haven't read this draft, so maybe it's totally awesome about this, but it'd be really good to define what the assumptions are. In particular, I assume you're not trying to conceal the fact that the fronting server is in fact a fronting server for these guys, because of course that's hopeless if you're going to put the damn thing in the DNS.
Right.
So it'd be good to figure out, map out. I'm not saying this. I think this seems like a good idea, at first glance. But it'd be important to map out exactly what you're trying to conceal, what you're not trying to conceal.
Right. So that draft does talk about one possibility of having an HTTP fronting server, and concludes by saying there are discoverability issues with how would a client know what fronting server to use. These drafts set out to solve that particular case, while Christian's draft goes on to outline a TLS generic solution that requires a little more knowledge and cooperation from the server side.
Okay, thank you. So just to clarify, authors, you are asking us to adopt these drafts, correct?
At some point, not necessarily today. If you think they're ready, go for it.
Do you think they're ready?
Probably.
Probably.
I have no outstanding issues right now.
Anything to add?
I would appreciate adoption, if only because we need, we need the attention to make it better.
Sure. So let's keep it simple, at least to start. We'll do two hums. First will be if you believe that these documents as a pair are ready for adoption, and if you do not, the second hum. And if we have the second hum prevail, perhaps we'll explore a bit further. So if you think that both of these documents are ready for adoption, please hum now. And if you think that for whatever reason they're not ready as a pair for adoption right now, please hum. Does anybody want to get up and explain why they hummed in the negative? Briefly.
They're not ready.
Okay.
I think I'd like to
do
see
you
a
have
little bit more
a
review.
suggestion how they can be ready other than more time?
I think I'd like to see some people discussing the drafts a little bit more on the list.
Quick question, show of hands, who has read the drafts? Okay. All right, we'll take that on board.
Okay.
Thank you. So finally, I have a last presentation, which we've talked about before, so we'll do it quickly. Do you mind pressing the space bar? So we've talked about variants before. Next slide. Right now we're at draft 02. There are a couple of outstanding issues. They're not significant, I don't think. They're just stuff we need to work through. We have a toy implementation to prove the inspec algorithms and make sure that they actually work. And I believe that it's suitable for prototype implementation. Next slide. So this is an example, just to refresh your memory. The variance header explains or conveys the request headers that are helping to form the secondary cache key, along with the possible values for each request header. And the variant key says which of those values was used to select this particular response. Next slide. The previous proposal that is in this space, which the working group adopted and then parked after we kind of stalled on it, was key. Key is different in that you basically ship an algorithm in a response header that says how to determine a secondary cache key for a particular resource. Whereas variant, that algorithm is in the spec of the headers themselves. So it's fixed. This has a number of trade-offs. It's a little more rigid, but it's a lot more reliable for the server to produce the right response header. The big bit of feedback we got on key was it seemed like a big old foot gun that people could shoot themselves with. And also there was a lot of implementer reluctance to adopt key. They were concerned about the unbounded nature of it. Whereas variant is much more constrained, and from the implementers that I've talked to, there seems to be a lot more excitement about it. Next. So should we adopt it? I think it's ready for adoption. Putting my Fastly hat on, Fastly seems like it's interested in this. I've talked to a couple of cache implementers who seem like they're interested in prototyping it and playing around with it. So the question is this ready for adoption, or do we want to wait a bit longer?
Is Leif in the room? Is Leif in
I
the room?
don't think Leif is here this time.
All right, he provides some
I see no
positive on-list comments.
Yeah.
So,
Leif is very positive about it.
so is there any comments that we'd like to make before we move to the last hum that stands between you and an evening out?
So Martin Thompson, this is not me. This is Mike relay for someone who's in the...
Mike who?
I'm relaying something from the Jabber room from Tom Peterson, who says, it appears this spec either denormalizes or writes off the questionably used quality value indicators, which are common in accept lang. Is that the goal?
That's the he's talking about the accept header, correct?
Yes, and I imagine there are, is it using other ones?
No, it uses the quality value.
Okay.
I believe, yeah.
Okay.
Yeah. I'm happy to talk about the specific algorithms and adjust them if we can come to consensus. It's just whether this overall approach is the right one.
Do we have enough people in the room that have read the draft to make that decision, or do we need to go to the list? Can I have a show of hands if you've read the draft? Maybe 10. They went down almost as fast as they went up, but on the order of 10. Do you feel like that working set is enough to help you make this decision?
Well, so I'm not making the decision.
Well, make the decisions, in your draft going forward. Let's hear what Roy has to say. If these are your reviewers.
I mean, I may be confusing Jess, but I thought you had already asked for this on the list and got a list of responses on the list.
No?
I think we did an FYI and asked people to review the document, pointing to the individual submission.
So they should be counted too.
Yeah, it seems to have had positive. It seems to have had positive engagement on the list. Yeah, that's a good point.
Right. So I think we'll take a hum and then we'll take confirmation of it to the list. I think that's probably the right thing to do with a small sample size. Okay. So those in favor of adopting this as a working group item, please hum now. And those who think this isn't ready, please hum now. Okay, well, that was, a modest hum for the first and an empty-ish hum for the second. So I think we'll confirm that I'm in the list, but we have another document to add to our set.
Maybe one question. We've parked key. Should we abandon that or keep it parked?
That was the assumption in previous discussions of this. I should have brought that up, but that this would replace key.
Does anybody have any heartburn with that? Okay.
Okay. Oh,
Key
Roy gets the
key
last
co-author
word.
Roy Fielding.
I guess since I'm a co-author, I should say I'm fine with parking it or abandoning it.
It's been parked.
Right. So as long as it's not a milestone, that's great.
Yep.
Yeah.
Okay. That brings us to the end of our work. Thank you, everyone. Oh, Ted's got one last comment, and we got 1 minute left.
No, it was actually a question to you. You spoke feelingly at the SEC dispatch meeting earlier today about possibly having the people in this room look at some of the work that had been brought before it for a PEP. Do you want to give pointers while you have everybody with you?
So Ted is referring to the ATLS draft, application level TLS, which defines the mechanism of establishing a TLS tunnel using a series of HTTP messages as well as some other methods. And you might really want to have a look at that. Coming to a BOF, I suspect, in a future meeting. Thank you. You're off.